That's not a small problem. That's a civilization scale vulnerability.
Honestly, one of the most dangerous half-truths in cyber security right now. Encryption is a tool. The complexity outweighs the visibility, and when you can't see something, you can't protect it. I hear this all the time, and one of the most expensive misunderstandings. Here's the premise. Right now, the encryption standard protecting most internet traffic are
Hey everyone, welcome back to SecureDApp. As always, this is your host Kunal, and today I have been joined by Mr. Rahul Kumar, who is the product head of Quantum World. We will be moving further with him, but before that, let me just introduce myself. I am Assistant Manager Marketing at SecureDApp. Today, I was thinking that genuinely there are things that have been really going hard. So I have been in cybersecurity for years now. I have spoken with CISOs, I have spoken with CTOs, engineers, architects, people who build and protect millions of users every single day. And when I ask them what actually holds the internet together, they literally pause. They have no answers. Not because that they don't know, but because the real answer is so invisible, so deeply buried underneath everything we interact with online that even people inside this industry sometimes forget to say it loud. It's not passwords. Passwords are almost a distraction at this point. It's not firewalls, not antivirus, not even zero trust architecture. As trendy as that's become, the internet runs on cryptographic trust. Invisible keys, silent handshakes between systems happening billions of times every second. And here is the thing, most organizations have no idea of many of these keys they actually have, where those keys live, where are they holded, where or who particularly has the access of it. No answers. That's not a small problem. That's a civilization scale vulnerability quietly shifting underneath every bank, every hospital, every institution, and every organization where data is being collected. And exactly what we are pulling apart today. So let me introduce Rahul Kumar, who is a dear friend of mine as well as the product manager of Quantum World. So hi Rahul, how are you? I hope you are doing well.
Hi Kunal. Thanks Kunal for that warm welcome. So this conversation tends to get me getting friendly quietly once you start following the thread. So let's buckle up.
Okay, so that's the best possible way to start an episode. I hope so, Rahul. Uh, Coming back to the important part of this section, uh, let's build the foundation first because I think a lot of people watching or listening to this, even people with some technical background, have a fuzzy understanding of cryptographic trust, Rahul. Uh, what it actually is, how it is functioning. So let's start with the simple thing. If someone has zero, how do you explain what cryptographic trust means to them and why it matters?
Okay, forget technical terms for a second. So think about your morning. You wake up, you check your bank balance, you send a message on WhatsApp, or you scan a QR code to pay for coffee. You log into your work system on the cloud. Every single one of those actions works because of a silent agreement happening underneath the surface. Your bank is saying, I trust that this request is really coming from you. WhatsApp is saying, I trust that this message goes only to the person you intended. The cloud platform is saying, I trust that this device has the right to access this data. That trust, all of it is built of cryptographic.
Okay. And when you say cryptographic keys, Rahul, give me the simplest possible example or version of what it actually means.
Here's the analogy I always use. Imagine the entire internet is a massive city, okay? So inside that city, Every bank, every hospital, every government office, every cloud platform has a vault. And inside those vault is a sensitive data, financial records, medical histories, communications, and intellectual property. Encryption is the lock on those vaults. Okay? A very, very sophisticated lock. The cryptographic key is the thing that opens it. Now, here's where it gets important. It doesn't matter how strong the lock is. If someone steals the key, the moment the key is compromised, the lock becomes purely decorative.
Okay. Uh, and I think that's the part people don't fully grasp because when people hear encryption, they think, good, my data is safe. Full stop. They stop thinking over there. They don't think about what's happening with the key.
Exactly, and that mental model, encryptions equal safety, is honestly one of the most dangerous half truths in cyber security right now. Encryption is a tool, a powerful one, but it's only as strong as the management of the keys behind it. And the management of those keys, that's where organizations are falling apart.
Okay, Rahul, let's just go more deeper on that because I think there is a massive gap between what company thinks they are doing with the key management and what's actually happening on the real ecosystem.
Yes, huge gap. And here's why 10 years ago, an average enterprise might have had a few hundred cryptographic keys to manage, manageable. Okay, you could track them, audit them, rotate them on a reasonable schedule. Then cloud computing exploded. Microservices, the multi-cloud environments, then SaaS integration, then the third-party APIs connecting to the third-party APIs connecting to more APIs. Now that some enterprise isn't managing hundreds of keys. They are managing tens of thousands, sometimes millions, and the tooling and the culture around the key management never scaled to match that explosion.
So the complexity outgrew the visibility. You mean to say that?
Perfectly put the complexity out with the visibility, and when you can't see something, you can't protect it.
Absolutely. So, Rahul, let's talk about the infrastructure itself because I think there is something that doesn't get discussed enough, which is just how fragile a lot of this trust architecture actually is underneath the surface. People experience internet as it is stable and it is a permanent thing, but what about what's underneath it is?
Underneath it, it's a layer of assumptions and trust. And when you see that padlock icon in your browser, that little green or a gray icon that tells you a site is secure, people see that and think, okay, I'm protected. But what's actually behind that icon is that a certificate. That certificate was issued by a certificate authority, a company that essentially says we vouch for this website's identity. Behind that is a chain of cryptographic signature. And behind that is a root certificate that your device was preloaded with when it was manufactured. Sometimes years before you ever used it. That entire chain has to hold together every single time for the connections to be trusted.
And the most people have never once thought about any of that.
Yes, never, never. And honestly, that's by design. These systems were built to be invisible when they work. The problem is invisible systems don't get attention. They don't get investment. They don't get scrutinized until something breaks. And that is the problem.
Absolutely. Absolutely. So, Rahul, let's do a myth versus reality check here because I think this one is important. So, the myth is if my data is encrypted, it's safe. What's the reality?
The reality, if an attacker steals the key, your encrypted data is just organized chaos waiting to be sophisticated. Encryption without proper key management is like locking your front door and leaving the key in the lock on the outside. The lock did its job, the key management didn't. Okay,
And
and
that's
it
actually happens. It's not just theoretical, in my opinion.
constantly. Let me give you the categories because this is important. So the category number one is hard coded secret. Developers write cryptographic keys directly into source code because it's convenient. That code gets pushed to a repository, sometimes a public repository, sometimes that repository has been public for 2 years before anyone notices it. And second, cloud misconfiguration. An S3 bucket, an Azure blob, a GCB storage object, it gets set to public by accident. The encryption key is used to access other systems are sitting in there. Anyone who finds it now has a master key, something important. And then there is a third party exposure. Companies give API keys and access credentials to the vendors, partners, contractors. Those third parties have their own security posture. When they get breached, so do you. Through the keys you handed them. And there is an internal abuse also happening. Sometimes the threat isn't external at all. Privileged insiders with access to key management systems who either misuse that access or make mistakes that expose credentials. So these are the things.
Absolutely, Rahul. And what makes all of this so dangerous is that none of it makes headlines the way a dramatic hack does. It's quiet, it's slow, and by the time anyone notices it, the damage is already done.
That's exactly right. And because the impact is delayed, organizations often don't connect the breach back to the key management failure. They fix the symptom, and they don't fix the root cause. That is the biggest problem.
Okay. Rahul, let's just shift to the business side of this because I think this is where the conversation needs to go for a lot of leaders watching. So there is a question I constantly hear from executives. We are already in cloud. We use AWS, Azure, GCP. Doesn't that mean our security is handled?
Yeah, I hear this all the time, and it's one of the most expensive misunderstandings in enterprise security. Here's the model you need to understand. Shared responsibility, cloud providers, AWS, Azure GCP, they secure the infrastructure, the physical servers, the network, the hypervisor, the data center. They are genuinely excellent at that part. But the workloads running on that infrastructure, the applications, the data, the keys your systems use to communicate with each other, that's your responsibility. And cloud providers are very explicit about this in their documentation. Most of the customers just don't read it carefully enough and they face problem later.
Absolutely. So moving to the cloud doesn't simply simplify your key management problem. If anything,
It
it
multiplies it.
yeah, exactly. I was telling that only.
It can multiplies it because you are not running on an environment. You are running three cloud environments plus on a premise systems you haven't fully migrated yet. Plus 27 SaaS tools your teams adopted over the last 4 years, plus a mess of API connection, tying all of it together. And every single one of these connections is authenticated by a key, an API key, a certificate, a token, a secret. And those keys have life cycles. They need to be rotated, audited, revoked when employees leave, updated when service change. And that scale without dedicating tooling and processes, it becomes essentially impossible to manage manually.
So what does operating blind actually looks like for an organization? What are the warning signs we can say?
Good question. So here's what I see most often. The security team can't tell you right now exactly how many cryptographic secrets the organization has. They'll give you a rough number. The real number is usually 3 to 5 times higher. There is no centralized inventory. Keys live in different places, code repositories, configuration files, cloud secret manager, spreadsheet someone created in 2019 and forgot about email threads. There's no rotation policy or the policy exists, but isn't enforced because rotation would break things and nobody has time to fix without break what breaks and without breaks. And there's no alerting. Nobody gets a notification when a key is about to expire, when a key is being used in an unusual way, or when a key what should have been rotated 6 months ago is still active.
Absolutely. And if you are an executive listening to this right now, what is that one question you should be asking your security team today?
Well, ask them, can you show me a complete inventory of every cryptographic key and secret this organization currently has in use, where each one lives, who has access to it, and when it was last protected. If they can answer that question confidently and completely, you are in better shape than most. And if there is a hesitation, the answer is we are working on it or it's partially documented. That's your signal. That's the gap.
Absolutely, Rahul, I agree on it. So, excuse me. So, I want to make this real for a minute, Rahul. Not hypothetical in 20 years, real. The tomorrow is real. What actually happens if cryptographic trust starts failing at scale? Walk me through that.
Let's follow the chain. It starts small. A certificate expires on a critical authentication system, or a key gets compromised and starts being used by someone it shouldn't be. Systems that normally trust each other start behaving unexpectedly. The first aren't dramatic. They are annoying login failures, transaction errors, API timeouts, service degradations. That looks like normal infrastructure hiccups.
Absolutely, which means people aren't immediately alarmed. They are troubleshooting what looks like a normal outage.
Exactly. And that delay is critical because while teams are diagnosing what looks like a performance issue, the actual problem, compromised trust, is spreading. Now let's scale it up. Imagine that isn't one company. Imagine a widely used certificate authority has a critical failure, or a foundational cryptographic library used by thousands of organizations is found to have a vulnerability. Suddenly, you are not talking about one company authentication system. You are talking about banks unable to verify transactions, hospitals unable to authenticate access to patient records, in some cases, literally unable to unlock system needed for patient care, airports unable to process identity verification, cloud platforms unable to trust internal service to service communication.
Absolutely. And the terrifying fact or the terrifying part is that most people experiencing this wouldn't know that what's happening.
They experience payment declined, system unavailable, access denied, service outage, the surface level symptoms of something they have no framework to understand. And the deeper problem isn't just the immediate failure, it's the uncertainty. Because once trust collapses, you can't just flip a switch and restore it. Okay. So trust by definition has to be rebuilt carefully, verified, re-established layer by layer. And that takes time. In critical infrastructure, time costs lives and money. In a way, they are very difficult to outsource.
How close to that scenario are we actually operating right now, Rahul? Not worst case, just the current reality, if I talk about.
Closer than most people are comfortable admitting. We already see similar versions of regularly. So let's encrypt root in certificate expiration in 2021 caused widespread disruption because devices running older software didn't have the updated certificate chain. Older LOT devices, industrial system, embedded software, they just stopped trusting things. That was a manageable event, but it was a very clear demonstration of how interconnected and fragile this infrastructure actually is. The question isn't whether these events will happen, they will. The question is whether organizations are positioned to respond quickly when they do.
Absolutely, Rahul. So let's go to the horizon, Rahul, because this is where the conversation goes from serious to genuinely alarming. There is a concept you mentioned before we started recording. Harvest now, decrypt later. Explain that because I think it reframes the entire urgency of this conversation.
So, sorry. Here's the premise. Right now, the encryption standard protecting most internet traffic. RSA, elliptic curve cryptography are secure because breaking them would require computational power that doesn't yet exist. Even the fastest classical computers would take millions of years to factor the math behind a modern encryption. But quantum computer changes that equation fundamentally. Quantum computers, when there is sufficient scale, can theoretically run algorithms that break RSA and elliptic curve encryption in hours, maybe in minutes. We are not there yet, but sophisticated threat actions know that, and some of them have a very rational strategy: steal the encrypted data now and decrypt it later when the tools exist to do so.
So attackers aren't necessarily trying to read our data today, they are collecting it. Am I right?
I'm building a library of it right now. Encrypted traffic intercepted today, encrypted files exfiltered today, stored away, waiting for the decryption capability that's possibly somewhere between 5 and 15 years away. Now think about what kind of data have a very value horizon that long. Government communication, military intelligence, long-term financial strategies, medical research, legal documents, industrial designs, infrastructure blueprints. Anything where the information will still be sensitive or actionable a decade from now is target for harvest now, decrypt later attack. And some of that data may already have been harvested.
And the response to this is not just a software update.
Not even close. This is a migration problem at civilization scale. We are taking about transitioning every encrypted system, banks, governments, cloud platforms, healthcare networks, critical infrastructure to a new post-quantum cryptographic standard. NIST has been working on standardizing this. These standards are coming, but implementation, we are rebuilding the cryptographic foundation of the entire internet. That's not a patch, that's a construction project measured in years with enormous coordination challenges, compatibility issue, and transition risk.
Absolutely. And the organizations that started thinking about this now versus the ones that wait until it's urgent.
The gap between them will be enormous because the organizations that start now get to migrate on their timeline with adequate planning in controlled way. The one that will get to migrate in a crisis.
Absolutely. Rahul. So, Rahul, thank you so much for joining. So here it what strikes me about this entire conversation, Rahul. We have talked about infrastructure that billions of people depend on every single day, infrastructure that holds together banking, healthcare, communications, e-commerce, commerce, government, essentially everything. And most of the people responsible for protecting that infrastructure are under-resourced, operating without fully visibility, managing complexity that's grown faster than their tools can handle, and facing a future threat that requires them to rethink everything they have built. That's not a small problem, I think. To close the podcast, Rahul, what is the final take?
No, and I think that's actually the most important thing I'd want people to take away from this. This isn't a nice technical issue. It's not something that only matters to security teams, cryptographic trust, infrastructure is. At this point, foundational to civilization in the same way power grids and water systems are. We just don't talk about it that way. The organizations that recognize that threat, key management and cryptographic hygiene with the same seriousness they treat physical infrastructure are the ones that will be positioned to survive what's coming.
And the one who doesn't or
They'll
who
find out
don't?
why.
Absolutely, Rahul. So, Rahul, genuinely one of the most important thought-provoking conversation I have had on this topic. Thank you for not making it comfortable.
And that's the only way.
So thank you, Rahul. Thank you for joining. Thank you, people. If you like this video, if you really understand the importance of quantum threat and why quantum world as a product itself is important, please hit the like button. You will find quantum world. You can go to our website quantumworld.tech and understand why and how quantum world can help you in the quantum threat ecosystem. So with that, I sign off and thank you for watching. If you like the video, please hit the like button. Share this video with your friends, families, and colleagues. Subscribe to our YouTube channel, SecureDApp. We will definitely see you next time. But till then, stay safe, stay secure. And as always, I say, stay ahead. Thank you for joining, Rahul. Thank you so much.